Hello everyone, welcome to Oracle CloudWorld 2022. My name is Deepak Goel. I'm a Senior Director of Product Development in Database Organization. And along with me, I have Brijesh as well. So Brijesh, you want to introduce yourself?
Yes, hi everyone. So my name is Brijesh and I'm a CMTS in the Oracle database group. And I am the product lead for this product, the Oracle Transaction Manager for Microservices.
Yep. Welcome again. So today we are going to talk about Oracle Transaction Manager for Microservices. So this is a new product that we are implementing. We have just launched and announcing for the first time at Oracle CloudWorld. And this is the agenda. We are going to talk about some challenges with microservices application development, provide an overview of the product, data consistency spectrum that we support, and how simple it is to develop application using the product. Also, what flexibility as well as some roadmap and upcoming feature for the product. So let's start with the challenges with microservices. We all know microservices are very distributed. There could be tens, hundreds of microservices working in an application, and each microservice has its own database. The challenge here that we are focusing on is the data consistency across these data resources. So how do you make sure that when your business transaction is going through, the data is consistent across all the resources being used in the application and across all these microservices? And one may ask that why data consistency is necessary. There are various reasons. There are business transactions in financial applications where you are withdrawing from one account and depositing in the one account. It has to be an atomic transaction. Otherwise, you might end up saying, where is my money? I withdraw it, but it's not deposited into the account. And the other account, the bank manager can say, okay, I don't know where that money is. So issues like that might happen. Same thing with the supply chain or this retail business. When someone is placing an order might be placed, but the payment may not be received. So these kind of issues might be there, and that's why data consistency is necessary. And it may also lead to customer dissatisfaction, because if order is placed and payment is not done, if payment is done but order is not placed, all those kind of things might happen. It may also lead to the legal hassle. There are various ways data consistency issue is addressed as of today. Manual reconciliation. So this is one of age-old solution. You do this reconciliation at the end of the day, week, month, whatever it is, and then you see data in this source versus that source, whether it's consistent or not. It's very error-prone, it's very time-consuming, it's very costly, to say the least. Other is the developers actually doing their own transaction management. Now the burden is on the application developer to put all the logic for the transaction management infrastructure in the application. That's not cost effective, and it takes the precious time from the developers from the business logic to this transaction management, which is not necessary. There are a few existing transaction managers out there as well, but most of these transaction managers are focused only on Java. Microservices are being developed in many different languages. Java is just one of them. And these are open source. They don't really provide the enterprise level solution that we are aiming for. So there is a clear need for enterprise solution to address this data consistency, and especially for the microservices based application. So let's get into right into the product that we are offering. Our vision for this product is much more than data consistency. We want to provide a product that enables actually all the application developers to adopt and increase the use of microservices-based architecture in their application and make it easier for them to develop and deploy such application. Data consistency is the issue that we are focusing in this first release, and we are going to talk about that. So what is Transaction Manager for Microservices? We call it MicroTX as well. So again, you would heard this data consistency word again and again, because that is our focus for this release of the product. So Transaction Manager for Microservices, MicroTX, it enables use of distributed transactions to ensure the data consistency, and it is specifically designed for microservices-based application. Now, these microservices could be written in many different programming languages, Java, Node.js, and so on. It could be developed using different application frameworks or platforms. It might be deployed in Kubernetes or other infrastructure wherever your microservice is running. It supports heterogeneous resource managers like Oracle Database, MySQL, PostgreSQL, all those kind of resource managers could be part of a distributed transaction. And then it could also utilize existing services or application in the same XA transaction. So microservices don't have to operate in the silo, so to speak. And in order to do that, what we are introducing is basically two components here: the transaction coordinator, that's what we are doing, and the micro-TX library, which links with the application. So you're saying like the two components of this product, transaction coordinator, this runs as a microservice. It actually is a microservice. So basically, wherever you are deploying your microservice application, you deploy this transaction coordinator as well. And then micro-TX library here, this is linked with the application. So we provide one library for each programming language. So there is one for Java, one for Node.js that is linked with the microservice. All the communication between microservices and transaction coordinator, this is using the REST API. And among the microservices, whatever communication mechanism that you are using before, you continue to use that. We don't impose anything in addition to that. The transaction store, state store, the transaction coordinator need to store the transaction state, and that can be done in an etcd or Oracle database. So with this product, basically it reduces the application complexity significantly because now all the transaction management burden is on this product rather than on the application developer. Application developer doesn't have to worry about the infrastructure for distributed transaction. It increases the developer productivity, and then all the transaction protocols that we are supporting actually are industry standard, as you would see in the next slides. Obviously, if developer is more productive, there's a faster time to market. Now they are just focusing on the business logic rather than the transaction infrastructure. And one salient point for this product is that you can continue to leverage your existing assets and development framework. There is no new development framework that you need to use in order to make use of micro-TX. So let's talk about the transaction protocols that we support for this spectrum of data consistency. So the one protocol that we are supporting is XA. XA has been around for decades. Actually, it started from the mainframe days, then it went to the application servers like Tuxedo and WebLogic, and now we are bringing it to the microservices world. It's a two-phase commit protocol and provides the strong consistency. So either all the resources are updated or none of them are updated. It maintains the asset properties and use of XA is mostly transparent to the application. And when I say mostly, it means that you just have to use the transaction demarcation API in your application to demarcate which business logic you want to be part of the global transaction. XA has been around for decades, as I said, and it has been proven. It's used in thousands, millions, actually maybe billions of applications out there, and it's widely adopted, of course. So what we provide for XA, we have an XA compliant implementation. We follow the XA spec. As I said, XA has been coming from mainframe and Tuxedo and WebLogic. Tuxedo, we are from the Tuxedo team. We implemented XA for Tuxedo, and now we are bringing it to the microservices world. In the Java application, you just use the JTA APIs to demarcate the application transactions. And in TypeScript, we provide our own implementation of the API that you use for transaction demarcation. We have a very unique resource manager proxy approach that I'm going to talk in the next slide. And we also support this logging last resource. So using the logging last resource, you can have one non-XA compliant resource manager participate in the same global transaction along with other XA resources. Our implementation is highly optimized, actually, especially for database, but even for other database, there are various things that we have done, and you can expect higher throughput. So the unique resource manager proxy approach that I was talking about, as of now, most of the resource manager or transaction manager implementation requires that transaction manager talks to the resource manager directly. And this means that the transaction manager needs to know about resource manager specific library, it needs to link with those, because it needs to call the exe prepare, exe commit, exe rollback API directly to the resource manager. That also means that the transaction manager needs to have a connection to each RM that are part of the transaction. So if you're talking to 10 different RMs, there are 10 connections. And these connections are in addition to the application services, your microservices. And of course, the transaction manager also needs to know about the credential for RM. Our implementation of transaction manager, it's completely agnostic of the resource manager. We use the microservice or your application that you're using as a proxy to the resource manager. So whenever there is a time to call, exe prepare, commit, and rollback, we just talk to the your microservice that are provided as part of the MicroTX library. We recognize that these particular calls are for the resource manager, and using the resource manager proxy, we go to the resource manager. And that way, the transaction manager is not aware of exactly like which resource manager is being used by the microservice. We just talk to the microservice application. The couple of other distribution transaction protocol that we support, one is the Saga. Most of us are familiar. Sagas have been around for quite some time as well. These are generally used for the long-running activities. A typical use case there might be travel booking. So you're talking to a flight operator and a hotel operator, and these operators might respond at different times, which might be separated by minutes or even hours. So the exit protocol is not suitable for these kind of use case. So for that, we have the Saga, and we have implemented Saga using the Eclipse microprofile LRA implementation. With Saga, the application developer is responsible for providing this completion and compensating actions. So they are saying like, okay, if a transaction is completed, these are the actions, this is the business logic to execute. And if for some reason we have to compensate, in the case that one transaction was locally committed, but the other one was not, then this is the business logic to compensate the transaction for that particular resource. So there is a burden on the application developer to write this logic and make sure that these logics are operating correctly and test this out. Another transaction protocol that we support is try, confirm, and cancel. This is generally used for reservation-based model applications. So something like the travel agent booking or even movie ticket booking, seat bookings, those kind of use cases are applicable to this. This is a two-phase commit protocol as well, and it provides strong consistency, just like the exit protocol. But the only thing is the application has to adhere to this reservation state model. So application must be able to say that, yeah, this is just reserved, it's not committed transaction. And if transaction for some reason is canceled, then this reservation is aborted or reservation is reverted. As I mentioned that for Sagas, we implement Eclipse microprofile LRAs. There are certain annotations for Java. Those are provided in this spec. And then for TypeScript, we provide the annotation equivalent. APIs for transaction demarcation for TCC, those are very similar to LRA, simple APIs to use. With that, let me pass control to Brijesh, and Brijesh is going to go over how simple it could be to use MicroTX in your application and use these APIs. Brijesh.
Thanks, Deepak. As Deepak already mentioned, MicroTX provides an app library that a microservice must use in the application code to interact with the transaction coordinator. And the app library provides several annotations and configuration that add the transaction support in the application code for the XA, LRA, and TCC transaction protocols. The app library uses request and response filters or interceptors to propagate the transaction context and for automatic enlisting of participants in a transaction. This helps to hide the details of the communication between the coordinator and the participant, and also among the participant microservices. The changes that are required to use this app library are very minimal and will be explained in the next few slides. Let's go to the next slide. You can develop your microservices in Java or TypeScript, and you can also use some of the widely used application development frameworks for Java and Node.js, like Spring Boot, Helidon, WebLogic Server, or any asynchronous RESTful application that uses Jersey for REST, and then Express.js framework for the TypeScript applications. The app library automatically propagates the transaction context when requests and responses are exchanged between participant microservices. The app library has filters or interceptors that intercept an incoming request within a transaction context and automatically enlists a participant microservice with the transaction manager or the coordinator. The app library simplifies the application development by providing the callback APIs on a participant side, which the transaction coordinator can later call to commit or roll back a transaction. Having said that, let's investigate some example code to see that very minimal changes are required to use the app library. Let's begin with XA. So this is the XA initiator Java. So in an XA transaction, there are two types of participants. So the first one is an initiator that initiates an XA transaction, and then the other is a participant that participates in the XA transaction. So here the initiator application that initiates the XA transaction needs to only create the transaction boundaries by creating an instance of TRM user transaction. The transaction.begin call actually starts a new XA transaction, which can be committed or rolled back by calling the commit or rollback on the transaction object, which are shown in the highlighted text here. Let's go to the next one. Yeah. So in the case of a participant microservice, the participant microservice needs to first initialize the application library by providing an XA compliant data source, which is usually a database, which is shown here in the highlighted text. And let's go to the next one. And then the app library creates an XA connection to the provided data source and injects that connection into the application code. And the same injected connection must be used to execute all DML queries by the application code. So that is shown here in the highlighted text. In the case of LRA, participant microservices in Java, the LRA annotation as defined in the Eclipse microprofile LRA specifications must be used. The participant application annotates a JAX-RS resource method with the LRA annotation, which actually determines whether the method will run in the context of an LRA. And the participant application should also provide the other methods annotated with complete and compensate. These methods will be invoked when the LRA is subsequently closed or compensated. So that is what you can see in the highlighted text. Now, to ensure the transactional security with MicroTX, the functionalities provided by the transaction coordinator can be used along with some of the functionalities that a service mesh provides. For example, mutual TLS provided by a service mesh can be used for all traffic between microservices and the transaction coordinator. Similarly, JWT tokens can be used for user authentication. This has been tested with some widely used identity providers. And then the transaction token provided by the coordinator can be used for user authorization. And similarly, credentials can be shared using Docker or Kubernetes secrets. Let's go to the next one. The MicroTX Quick Start Guide helps to quickly deploy the transaction coordinator and the sample applications, and then run XA, LRA, and TCC transactions to understand how MicroTX works. And then there are out-of-the-box sample applications, which are actually example applications covering several use cases using XA, LRA, and TCC protocols that show how the app library in microservices can be used. So with that, we come to the end of this section.
Okay, thank you, Brijesh. So let's talk about the interoperability and deployment options that we have for MicroTX. So let's first go into deployment. As I said, that transaction coordinator, which is part of MicroTX, itself is a microservice. So wherever you're deploying your microservices application, this transaction coordinator can also be deployed. And all we need actually from the infrastructure is an overlay network and a request router or load balancer for all these REST API communication. So Kubernetes, of course, is a very good infrastructure out there, and most of the microservices are using it. So we support Kubernetes fully, along with the service mesh. We are certified with Istio service mesh and Envoy proxy. It can work with the Docker Swarm as well. And MicroTX is also natively integrated with the Kubernetes ecosystem, all the tools actually which are there in the Kubernetes ecosystem, like Kiali and Prometheus Grafana for monitoring, or ELK, FKStick for logging, and Jagger, and so on. We also provide out-of-the-box Helm chart for deployment of MicroTX and lifecycle management. As far as the resource manager are concerned, we support wide variety of resource managers here. Let's first talk about the XA compliant resource manager. For Java application, specifically any JDBC driver that implements XA data source and XA resource interfaces, MicroTX will work with that. So we have tested this with database, Oracle database, of course, and then PostgreSQL as well as MySQL. And it should also work with other RMs such as Microsoft SQL Server and DB2. Not only that, actually, MicroTX can also work with Oracle Blockchain Platform, which provides an XARM of its own. So now you can have blockchain distributed ledger update in the same XA transaction as an Oracle database or some other database. And all that can be part of the same global transaction. For Node.js application, we need to have a XA compliant DB driver that the resource manager should provide. We have one for Oracle database, and we have tested with that. As I mentioned earlier, that we also support logging last resource, or LLR feature, using which you can include one non-XA compliant resource manager in an XA transaction. So basically, any non-XA compliant resource manager can be used. We have tested with MongoDB. For LRA and TCC protocols, resource manager, MicroTX is resource manager agnostic. You can use any resource manager out there. So we talked about that, like number of a variety of resource manager can be part of the same global transaction, especially the XA part of it. You can have a JavaScript and Java application talking to many different resource managers, and even including the blockchain platform. But there might be a need to use or include other applications into this. So Tuxedo is one of them. Tuxedo has been around for 30, 40 years, and thousands of mission critical applications which are written in C, C++, or COBOL. Those are running in Tuxedo. So now you can include a Tuxedo service, which is written in these languages, in a XA transaction coordinated by MicroTX. And not only that, you can also have a database application that you can access using ORDS and Apex, an Apex app written in PLSQL maybe, be part of the same XA global transaction. And all the protocol actually from transaction coordinator to these existing application is using REST API. So this is the overall architecture for the product. Everything put together here. We have the transaction coordinator running as a microservice in Kubernetes cluster. You could have a variety of applications, including Node.js microservice, Java microservice, Tuxedo, could also be running in Kubernetes, and database, ORDS Apex app could also be running within the database. And on the resource manager side, you could have the database, Oracle Converge database, and blockchain platform as resources, as well as other resources. And all this is integrated into Kubernetes ecosystem, especially Istio Envoy as a service mesh and proxy, and then various tools for monitoring, Prometheus, Kiali, and so on. So let's look at the roadmap and upcoming feature. But before we go into that, how we are launching this product. So this transaction manager for microservices free, this is available now. This is the first time we are announcing at the CloudWorld. This product is available for you to download and play with. This is focused on developers to get started quickly and start developing transaction applications for most use cases. This is completely free product, no licensing cost whatsoever. You can also get support from Oracle if you have support for some existing products like Oracle Database, Oracle Tuxedo, or blockchain platform. Then we are also working on this enterprise edition of this product. This is going to be for production deployment, and it would have new features like high availability and extreme performance and scalability, etc., and for advanced use cases. And then we are also looking into providing an OCI specific SKU, mostly for pay-per-use pricing. Since it would be deployed in cloud, you should be able to pay based on your uses only. Might come up, what is the difference between free version and enterprise edition? So the number of transactions that you can do in an hour with free, that's limited to 4,800. With enterprise edition, it's unlimited. And I mentioned that availability and resiliency are going to be higher in the enterprise edition compared to free. Same thing with the optimization. As far as the roadmap is concerned, we have quite a few features in the current release. We are looking at to expand that with the introduction of Python and Golang as the programming language for developing microservices and support for LRC. And LRC is basically, it will allow us to enable the interoperability with Ethereum blockchain. And then high availability and scalability features, more database optimizations, as well as lifecycle management features like a console to manage the product, Kubernetes operator, and certification with other products, other platforms, other application development platforms. So with that, we have come to the end of this presentation, and I want to leave you with this slide on how to get started with the product if you want to play with this, and we invite you to play with this product and see how it fits into your use case, into your architecture. There are quite a few collaterals that are available on our website at oracle.com that you can avail. So there's quick start guide, data sheets, blog articles are there, white paper, and there is a live lab also available now that you can play with the product. It has everything set up in the product, in the live lab already. There is also a community support. So if you have any questions or you have any comment or feedback, you can use this community support forum to provide us with your feedback. So with that, let me just thank you again for joining us at Oracle CloudWorld and listening to this presentation about Oracle Transaction Manager for Microservices. Thank you.